In this video, we'll discuss the National Airspace and Airport Cybersecurity. This video was brought to you by the National Cybersecurity and Training Education Center out of Whatcom Community College. NCyTE Center and this material is based upon work supported by the National Science Foundation. My name is Philip Kreger. I'm a professor of cybersecurity at Embry-Riddle Aeronautical University in Daytona Beach, Florida. We're first going to review the National Airspace System and its components, and we'll also talk about Project NextGen, which has a large effect on the national airspace. Essentially, NextGen is a modernization of the national airspace. Then we'll talk about the cyber attack vectors on the National Airspace System, and then we'll move on to airport cybersecurity, which is a large part of the NAS. First, we'll talk about the prevalence of cyber attacks at airports. Then we'll talk about the studies of cybersecurity vulnerabilities that have been identified at airports in the United States. Then we'll talk about potential vulnerabilities and types of attacks that can occur at airports. And finally, we'll discuss mitigation strategies for these vulnerabilities. But first, let's look at a very recent story that just occurred a few days before I made this video. According to news sources, technical issues hit 3 U.S. airlines, which resulted in the grounding of flights. So what happened? Well, the 3 U.S. airlines were hit with technical issues that were causing flight delays and were hampering ticket purchases. Southwest Airlines saw the biggest problems when its weather data provider went down, making it unsafe for planes to fly. A Southwest representative said, "While the vendor worked to restore connectivity, we implemented a ground stop to protect safety of our crew and our customers." Delta Airlines and Alaska Airlines also saw issues affecting booking and apps, but flights were not delayed for these airlines. As it turns out, there was not an immediate resolution to the problem, as Southwest flight delays cancellations extended into a third day. Now, as it turns out, there was no apparent malicious actor involved with these incidents. However, nevertheless, availability of purchasing tickets and making changes in safe flight were affected, causing some delays. Now, apparently there were no malicious actors involved, as I said, so what does this have to do with cybersecurity? Because, as most people think, cybersecurity has to do with protecting our information assets from malicious actors. Well, as it turns out, this story has everything to do with cybersecurity. As we've stated in other videos, there's properties of information that need to be protected. So what are these properties? The first is confidentiality. And confidentiality involves limiting computer systems and information access to authorized users and for authorized purposes only. Second is something called integrity. And integrity involves ensuring information and systems are not modified by unauthorized users and that the systems function as designed. And finally, availability of data. And this involves ensuring information and services are available to authorized users when needed. So if you look on the left, notice that the C and the I and the A are bolded. This is called the CIA triad, and their properties of information needs to be protected. So in the case just discussed, we will see that the integrity of the systems was infected because they couldn't function as designed, and also the information that was needed, whether it was the flight data or information from apps, was not available to either the airlines or to passengers. So this demonstrates that it doesn't require a malicious actor for outside forces to affect the cybersecurity of a system. These types of cybersecurity issues can have a great impact on the financial stability and the safety of flying passengers. Over 16 million flights are handled by the FAA yearly. And this was a screenshot that was taken from FlightAware, flightaware.com, yesterday, showing the current planes in flight at one particular time. And because the national airspace is such an intricate system, a single delay at any airport can have a greater effect upon, not only upon other flights, but also other airlines and other airports. In order to increase the reliability and safety of flight, the FAA and the United States government have come up with a program over the last decade called NextGen, which stands for Next Generation Air Transportation System. And NextGen is a modernization effort that began in 2004 by the FAA to transform the nation's ground-based air traffic control system into a system that uses satellite-based navigation and other advanced technologies. NextGen is a multi-year incremental transformation that will introduce new technologies and leverage existing technologies to affect every part of the national airspace. These new technologies will use an Internet Protocol IP-based network to communicate. So in other words, the technologies that are underlying the national airspace in the future will be based on the same types of technologies and protocol that we use to run the internet and the World Wide Web. So the introduction of IP-based communications will provide system-wide interconnectivity between the ecosystem we know as the National Airspace System. And so some of the benefits provided by the IP-based technologies include a reduced workload, increased terminal capacity, a single weather source, 4-dimensional trajectories for fewer conflicts between aircraft, and something called automatic dependent surveillance broadcast that we discussed in a previous video. So with NextGen and modern aircraft, the critical flight systems are computer-based and are network-enabled. These systems include the electronic flight bag, the System-Wide Information Management System, or SWIM, the Flight Management System, and as we've discussed before, the Automatic Dependent Surveillance Broadcast, which is a surveillance technology in which an aircraft determines its position via satellite navigation or other sensors and periodically broadcasts it, enabling it to be tracked. And these signals are sent not only to ground-based systems, but also to other aircraft nearby. And finally, we discussed something called ACARS, or Aircraft Communications Addressing and Reporting System, which is a digital data link system for transmission of short messages between aircraft and ground stations via airband, radio, or satellite. So all of these critical flight systems now depend upon the information communication technologies, computers and chips, as well as IP-based messaging systems. Now, if you've watched the videos on the maritime transportation system, we look at that as not necessarily a single monolithic system, but it's actually a system of systems, and it's the same thing for the national airspace. The national airspace is a system of systems. It includes many different components, including air navigation facilities such as ADS-B, primary and secondary radar, equipment and services, airports, which we'll be discussing a little bit later, or landing areas, aeronautical charts, information and services, rules, regulations, and procedures, and technical information, and manpower and materiel. If we look at an expanded view of the national airspace, we see that there's even more parts to that system, including air traffic control operations, airport operations, maintenance operations, airline ground operations, airline flight operations, airline IT infrastructure, and passenger services. All of these services work together, and many of these services have connections, IP-based connections with each other in order to ensure safe and reliable flight. But for each of these parts of the NAS ecosystem, there are various types of cyber attacks that can occur to have an influence upon the entire system, including, for example, air traffic control jamming, attacks at airports, ACARS spoofing, something that we discussed in a previous video, ADS-B spoofing, something again we discussed in a previous video, attacks on the supply chain. If you haven't looked at the supply chain cyber attacks videos, please do so. Attacks on the portable electronic flight bags, GPS jamming, attacks on the airline infrastructure, or financial attacks, and of course attacks on the internet. Any attack on the global infrastructure on the internet can have an effect upon any service that is relying upon the feedback from the data feeds from the internet. Okay, now that we have a nice broad overview of the national airspace, let's turn our attention to airport cybersecurity. And the reason I chose this is because this should be very familiar. Almost everybody has flown on a plane. Everybody has visited an airport. Before we go to the next slide, I want you to try to guess how many airports you think that there are in the United States. So why don't you pause the video for a second and try to guess. It turns out there are almost 20,000 airports just in the United States, over 5,000 public airports, and almost 3 times as many private airports. So the problem of airport security has been acknowledged and discussed during testimony under the U.S. Homeland Security Committee's Cybersecurity and Transportation Security Subcommittee in 2018, where it was charged that cyber attacks without question represents the preeminent and persistent threat to global aviation, and that the operational importance of these systems makes airports immensely appealing targets and potentially vulnerable to malicious cyber threats such as criminal organizations and state-sponsored actors. It was also noted that U.S. airports have reached a point where voluntary compliance is no longer adequate. And it was also suggested that lawmakers should consider mandating the adoption of uniform minimum cybersecurity standards and frameworks. Now, this testimony was given in 2018, and still there are no uniform minimum cybersecurity standards and frameworks, but it is being discussed. So if you're like me, the first question you may ask yourself is, well, you've only given one example. How widespread is this problem? Well, as it turns out, the example I gave you is not a one-off issue. A study was conducted and it was reported in early 2020 that the airport security concern is 97% of the world's top 100 airports fail cybersecurity tests. The study went on to discuss the fact that 97 out of the 100 of the world's largest airports have cybersecurity risk related to vulnerable web and mobile applications, misconfigured public cloud, and dark web exposure or code repository leaks. So specifically, what were these vulnerabilities? So let's look at the main airport website cybersecurity. The study found that 97% of the websites contained outdated web software. 24% of the websites contained known and exploitable vulnerabilities. 76 and 23% of the websites were not compliant with data protection regulations. That includes both personal information as well as the processing of credit card information. 24% of the websites have no encryption or use obsolete encryption. And finally, 55% of the websites are protected by a web application firewall, meaning that 45% of the websites were not. It's only been in the last few years that now airlines and airports have mobile apps that help you with booking flights, changing flights, and so on. And so now I can't think of an airline or an airport that doesn't have their own mobile application. Well, as it turns out, there were quite a few security vulnerabilities identified with these mobile applications for these airports. For example, it was found that 100% of the mobile apps contained at least 5 external software frameworks, which generally means that the mobile apps were using either data or software from other locations or other entities. The study also showed that 100% of the mobile apps contained at least 2 vulnerabilities. 15 security or privacy issues were detected per app on average, and 33% of the mobile app's outgoing traffic had no encryption. And the final category of issues dealt with dark web exposure, code repositories, and cloud storage. So the study showed that 66% of the airports are exposed on the dark web. First of all, let's define what the dark web is. The dark web is the hidden collective of internet sites that are only accessible by a specialized web browser. And the dark web is used for keeping internet activity anonymous and private, which can be helpful in both legal and illegal applications. What this study found was that data from airports and customers that had been stolen in breaches was identified on the dark web. The study showed that 72 out of 325 data exposures are of critical or high risk, indicating a serious data breach. 87% of the airports have data leaks on public code repositories. And public code repositories are simply a file archive or a web hosting facility which has source code for software or documentation or web pages and other works. The study found that 503 out of 3184 leaks are of critical or high risk, potentially enabling a breach. And 3% of the airports have unprotected public cloud with sensitive data. A second study that used similar metrics as the previous study and applied to major airports in the United States, and as you can see on here, that on a scale of 0 to 10, with 10 being the highest threat index score, that many major airports in the United States are failing to secure their systems. So let's look in depth at these airport cybersecurity vulnerabilities. And according to the study, airport cybersecurity is often poorly rated, with 1 in 4 airports having received an F grade for issues like using outdated software with known and exploitable vulnerabilities, failing to encrypt between servers and clients, running old and now obsolete versions of encryption software, failing to secure mobile apps, fix known vulnerabilities, and encrypt outgoing data, losing highly confidential data like financial records and passenger ID information to the dark web, storing sensitive data on unprotected public clouds, and falling short of the European Union's General Data Protection Regulation, the GDPR, and compliance with standards, and that refers to personal data. And finally, failing to comply with the Payment Card Industry Data Security Standard, PCI DSS requirements, and that is for the processing of credit card data. And just to make sure this presentation is fair, I also am showing the top 10 least vulnerable airports in the United States, of which apparently at this time, Chicago Midway International Airport only achieved a threat index score of 4.5, still suggesting that the cybersecurity at one of the most traveled airports in the world is still not perfect. And if you're like me, one of the first things you do when you get to the airport is you fire up your mobile and you connect to the airport's Wi-Fi. I also use the electronic boarding passes and liberally use the airlines and the airport's mobile apps. But also realize that it's easier to access and exploit data from devices connected to Wi-Fi in an airport than it is to do so within the confines of a well-protected office, because those well-protected offices will have more stringent policies and most likely better security than does the open Wi-Fi access points at an airport. So now let's look at some cyber attacks at airports. The Israel's Airport Authority indicated that they have to block 3 million attempts to breach its system every single day. They said that these external threats try to breach the virtual fence of cybersecurity protections the airport's authority has built in to protect the workings of the airport and border crossings it operates. The authority noted, "We have our challenge cut out for us." In 2018, the Hartsfield-Jackson Atlanta International Airport's Wi-Fi services was down amid a cyber attack on the city. The airport, which is the world's busiest by passenger traffic, shut down its Wi-Fi and limited some information, such as wait times, on its website out of an abundance of caution. Atlanta's information management team discovered that some of the city's computer systems, including those that process municipal bill payments, had been compromised in a ransomware attack. So although there was no direct attack upon Hartsfield International Airport, the fact that the city itself had been hit by a ransomware attack ended up having an effect upon the airport itself. So recall earlier we were talking about the 3 properties of information we need to protect: confidentiality, integrity, and availability. This attack affected the availability of services. Recall earlier we mentioned that people or employees can be a threat to airports. Well, here's an example where the Heathrow Airport was fined £120,000 for failing to secure sensitive data after an employee lost a memory stick that contained confidential information. The memory stick contained information such as the Queen's travel routes, a training video that exposed the names, dates of birth, and passport numbers of 10 people, and personal data of up to 50 Heathrow aviation security personnel that was not password protected, and the data was not encrypted. Recall in a previous video we talked about the importance of training and education for all employees. Well, this study found out that just 2% of the 6,500 workers at Heathrow were trained in data protection, and urged the airport to improve education on the subject. And the final example for this video, and by the way, this is just a select few that I've identified, was a data breach by Cathay Pacific Airlines. Data for nearly 2.4 million passengers was at unprecedented risk after their personal information was accessed in a security breach. This data that was disclosed included passport numbers, identity card numbers, travel history, email addresses, and expired credit card details. Now let's look at some concerns involving the airport network vulnerabilities that you should be concerned with as a flying passenger. And these include Wi-Fi access points that can be vulnerable to unauthorized access through weak encryption. Confounding this fact is that personal use, or those ad hoc access points that you can create on your smartphone, are difficult to detect and may not be adequately secured. Physically unprotected and accessible Ethernet cables and/or ports at abandoned or unused gates. And malicious actors at the physical airport can create rogue Wi-Fi access points, which they can then create to mimic the actual Wi-Fi access points at the airport. Unsecured Wi-Fi access points to control systems and or other networks, some that are operated by third parties without adequate authentication and security protocols. For example, fuel trucks, HVAC systems, and baggage handling units, and even catering. Now let's look at mitigation strategies for cybersecurity vulnerabilities at airports. The first is that the airports need to understand their attack surface. And this includes understanding what information assets they have and what needs to be protected and to what degree. And by information assets, that includes not only data, but also the computing devices that are connecting to the airport's network. They should run continuous discovery programs and perform constant inventories of digital assets. And this is something that's done and it's been discussed before by system administrators, just running network scanning programs that determine what types of computing devices and how many computing devices are plugged in to the network. And this is an automating process that can be easily done. By running these discovery programs, the airport gains visibility into risk exposure from outdated software, known and unknown vulnerabilities, misconfigured systems, undetected malware, and unsecured access points across websites, the clouds, and on-site systems. And NCyTE has a couple of videos that actually show you how to do this on your own home network. The first is a video on how to do a network scan. And essentially what this tells you is that you connect to the network, you run the scan, and the results will show you what devices you have attached to your home network. And the second part is something called a vulnerability scan. And this allows you to identify any known or unknown vulnerabilities on the devices connected to your network, whether these devices are misconfigured, and whether they have any undetected malware. And finally, for airports, conduct an in-depth cybersecurity audits of their vendors and suppliers and implement a third-party risk management solution that goes beyond paper-based questionnaires to immediately expose the riskiest cyber issues with the supply chain. Remember, we started this video talking about the national airspace and even airports as being systems of systems. Well, if you consider all the third-party vendors and suppliers that we'll find at airports, including sometimes the airline catering or maintenance or HVAC workers or even shop vendors, these third parties often have access to certain segments of the network, but it's important to understand who these people are and what type of devices that are connecting to the network so that a risk management solution can be created and applied. And finally, let's look at your personal protections at airport. Again, one of the first things I see at an airport when I walk in is everybody's on their mobile phone or their iPad or their computer. Well, how do you protect yourself at an airport? The first thing is be careful when connecting to the Wi-Fi access points at the airport. For example, some Wi-Fi access points may not even be encrypted, or they will use weak encryption, which could mean a third party, a malicious actor, may have access to any of the information that you're sending to and from the internet. Or a malicious actor can set up a rogue access point. And what that simply means is that they've created a hotspot, or they've actually got a physical access point that they've plugged in somewhere that has the same name as the Wi-Fi access points at the airport. There's nothing to say that a rogue actor or malicious actor couldn't do that, which means that this malicious actor would be able to read any information that you're sending through that access point. Now, when in doubt, you can use a virtual private network. So what is a virtual private network? It's usually software that gives you online privacy and anonymity by creating a private network from a public internet connection. And you can find these usually on your smartphones or through their operating system or through a third-party solution. For example, I use something called Private Internet Access, which runs on all of my Macs or on any of my Windows systems and even on my smartphones. So essentially, this gives you a double layer of protection. And this is particularly important if you're sending or receiving sensitive data over the Wi-Fi access points at an airport. And probably one of the most important things is to make sure you maintain physical possession of your electronic devices. There's an old saying by malicious actors, or actually they were called hackers back in the day, is that if somebody can gain physical access to your electronic devices, that they own those. Never leave your physical devices anywhere where they're not in your possession. Now, to summarize what we discussed, we first reviewed the National Airspace System. We talked about Project NextGen's effect on the NAIS by making a lot of the services IP-based. We talked about cyber attacks on the national airspace. And then we talked about airport cybersecurity. We discussed the prevalence of attacks at airports. We talked about the studies on cybersecurity vulnerabilities at airports and note that there was no airport that was identified that had perfect cybersecurity. We talked about the potential vulnerabilities and types of cyber attacks perpetrated by malicious actors. And we discussed mitigation strategies, both for the airports as well as for your personal protection while you are at the airport. This video was brought to you by the National Cybersecurity Training and Education Center out of Whatcom Community College.